Hello everyone. So today we are going to be analyzing quadratic functions in different formats. So you will need to have this reference sheet out in front of you, and we're going to be looking at quadratic functions in three different forms. So if you look at the three forms here, vertex form is one that we've already used when we did transformations of quadratic functions. And whether you call it y equals or g of x equals or f of x equals, basically this is the part that we're going to be focusing on. And in vertex form, you have an a, h, and a k. So a still represents whether the parabola opens up or down. The h represents the translation either left or right, and the k represents the translation, vertical translation, up or down. The vertex is given in vertex form, which is nice. You take the h value from the equation and the k value from the equation, and that will be the vertex in your parabola. So it will be this point, turning point on the graph. The axis of symmetry, that's important. The axis of symmetry is the vertical line that goes up and down through the vertex. So it has an equation of x equals, like all vertical lines. X equals is how all vertical lines are written, but then the number or the value at which it crosses the x-axis is what this h equals. And it's going to have the same value as the x-coordinate of the vertex. So that's nice. So the h value here and the h value here are the same. But notice that the vertex is a point, so you should write it as a number here, parentheses, a comma in between. And the axis of symmetry, you must have the x equals in front of the number to show that it is an equation of a line. But this is your equation in vertex form. The next form we're going to look at is standard form. Standard form is when the equation looks like this. It's kind of dark, but so your equation, whether you call it y equals, f of x equals, g of x equals, will have an x squared term, an x term, and a constant, where the a value is the same actually as what it would be in vertex form. The b this time represents the coefficient of the middle term, and the c represents the constant in this form. So we'll look at some equations in standard form. In order to find the vertex in standard form, you need to use the formula negative b over 2a, which is actually a piece of your quadratic formula that we had used when we were solving quadratic equations. The negative b and the 2a part, that is the part that you can get the x coordinate of the vertex, which has a special variable that we call h. So the h value in vertex form is equal to negative b over 2a from standard form, and that's going to be important. And then what this represents, the k value or the y coordinate of the vertex, is what you will get when you take that value that you got from negative b over 2a and you substitute it into the equation for x, both here and here, and whatever value you get, that is the y coordinate of the vertex, which is also the same as k in vertex form. The axis of symmetry is x equals negative b over 2a. So again, that value there is h, just like here it's h. So if we just take the formula negative b over 2a and we calculate that, don't forget the x equals must be in front of that number to show that it's an equation of a line. The other piece of standard form that's convenient is when it's in standard, when an equation is in standard form, or the quadratic equation function is in standard form, the y-intercept is the constant. And that is because, so it's the y-intercept is equal to c, which is the point 0c. So the reason why the y-intercept is the constant is because if you were to substitute 0 for x, these terms would basically become 0, and all you would have left was that constant. So to find the y-intercept of really any function, you would just substitute 0 for the x values and simplify, and that will give you your y-intercept. All right, so we're going to talk about intercept form in a minute, but let's get to doing some of the work. So right now you're going to need to have this worksheet in front of you. It's 2.1. I've renamed it 2.1, Analyzing Graphs of Quadratic Functions. So this first equation here, I'm going to let you do problem number 1 on your own. That's going to be one of your homework problems. And we're going to look at problem 2. So I'm going to be doing the even problems for notes, and you're going to be doing the odd problems for homework. All right, so this is the equation that you're given, and this is the graph that you're given. Now pretend that this graph wasn't here. Most in the next assignment, assignment 2.2, you're going to be given the exact same type of problems, but you will not be given the graph, and you will need to graph these quadratics on your own. So it's important that we pretend that this graph is not here. Everything that is underlined, you need to show work on how you
would solve that, how would you find it without looking at the graph. So you need to show algebraically how would you find the vertex if this was all you were given, was the equation in standard form. So this is standard form, and from standard form, the a value is the coefficient of your x squared, which is 2. The b value is your coefficient of the x term, which will be 4. And the c value is your constant. In this case is -3. So now, if you have your reference sheet in front of you, well, how do I find the vertex? You take -b over 2a, and that's going to give you the x-coordinate of your vertex. So off on the side over here, and I'm going to say h equals. So in standard form, you're given a, b, and c, but you need to find h and k. Well, h is just equal to -b over 2a. And -b, once again, is the opposite of the b value. So if the b value in standard form is 4, the opposite of that would be -4. And then 2 times a, in this case a is 2, so 2 times 2 would be 4. Then we always simplify. -4 divided by 4 is -1. So that's how you would show algebraically how you would find the x-coordinate of the vertex. That also tells you the axis of symmetry, but don't forget you must have x equals in front of it. If all you give me is a number, I'm not marking it, it will be marked wrong. So x equals -1 is the axis of symmetry. So that piece is done because we found that there. Now, in order to find k algebraically, we need to take that value that we got for h, which is the x-coordinate of the vertex. So even though we call it h, it is an x-coordinate. So it is an x value. So to find the y value that corresponds with it, we need to substitute -1 into the function. So we call it f of -1, which means the function with an input value of -1. So take this equation, 2 times -1 squared plus 4 times -1 minus 3. And then you can either plug that in the calculator or simplify it. For me, it's faster just to simplify it. -1 squared is going to be +1 times 2 would be 2. Make sure when you're simplifying this, you always square the number first, then multiply. Exponents before multiplication. All right, so this next middle term is -1 times 4, or -4, and then minus 3. So 2 minus 4 minus 3, I would think of that as -7, and a +2 would be -5. All right, so -5 is the y-coordinate of my vertex. So if I look at my graph, just to double check that I do have that correct, this is the point, well, this is -2 here, so these are going by half units. So this is actually -1 on the x value, or x-axis, and this is -5 on the y-axis, because this is -4 and -6. So -1, -5 is the vertex. And then we can also, on the graph, draw the axis of symmetry, make it a dotted line. So on tomorrow's assignment, or the 2.2 assignment, you will need to graph the vertex. You will need to graph the axis of symmetry. And then I like to label, you're going to need to label everything. X equals -1 is the equation of the axis of symmetry. All right, so that takes us, we did the vertex, we did the axis of symmetry. Now let's talk about the max or the min. So the max or min value is always equal to k. So on my reference sheet here, so the min value or minimum value is always equal to k, the maximum value is always equal to k. So what we're talking about is where on the graph is the lowest point or the highest point. If your parabola opens up, then the vertex is the lowest point on the graph, and your minimum value your minimum y value will be whatever that k value is. And then if your parabola opens down, the vertex is the highest point on the graph, which so k would be the highest y value on the graph. So in this particular equation, whether you look at the equation, the a value is positive, which tells you that the graph is going to open up, but we also have the graph here showing us that it's opening up. And we should have arrows here showing that it goes forever and ever. So the minimum value, so circle minimum to show that you understand that it's a minimum value since it's opening up, would equal -5, which is your k value. So again, that comes from the vertex. Now, if in other courses you're asked for the minimum point, so the minimum point is basically the vertex. So what you may be asked to do, the minimum is -5 at an x value, or let's see, I'm going to write it differently, when x equals -1. So you'll have a minimum value of -5, that's the y coordinate, when x equals -1. And that's the x coordinate of your vertex. Alright, so once again, the parabola has a minimum value of -5, so the -5 is the lowest y coordinate when x equals -1. Alright, moving on. Zeros, roots, solutions, x-intercepts. These are very related, but how you write your answers are a little bit different. So let's find the solutions first. So we've already solved quadratic equations, and what you do to find a solution or an x-intercept or roots of a graph or a function is to take the equation, the 2x squared plus 4x minus 3, and set it equal to 0. So to find any x-intercepts of any equation or any function, you set the equation equal to 0 and solve. So, we've already solved quadratic equations recently, so let's start with how would we solve this? Well, if we're solving with quadratic equation, whenever you have an x squared and an x term, you have a choice of either solving it by factoring or quadratic formula or completing the square. But if you tried to factor this, you would have to use AC method because you've got a leading coefficient of 2. The 2 cannot be factored out. So if this was factorable, I would have to multiply the a and c together, which would give me -6. So then I would be looking for two numbers that multiply together to equal 6 that have a difference or subtract to equal 4. Well, your factors of 6 are 1 and 6 and 2 and 3, neither which have a difference of 4. So that tells me I can't factor it. So that tells me right there, yeah, nope, can't factor it. So now we need to use the quadratic formula. So your quadratic formula, I have written here, is -b plus minus square root of b squared minus 4ac over 2a. And again, it's when in standard form. So your quadratic equation must be in standard form before you can use quadratic formula. And it must equal 0. Alright, so we're going to use quadratic formula with this. So the -b means the opposite of b. b is 4, so the opposite of it would be -4. Let me use, say x equals in front of there. And then your plus minus square root. Take the b value and square it. B is 4, so when I square it, I get 16 minus 4. And then the a times c was -6. And then all over 2 times a, since a is 2, when I multiply the 2 times the 2, I get 4. So that's my first step. And I like to simplify the -b, b squared, ac, 2a, those kind of things I do in my head so to make it easier on the next step. All right, so the next step, simplify this a little bit more. So this -4, I'm going to put over 4. Because really what you have here is a number, you have two terms, the -4 and the radical, that both need to be divided by that 4. So I like to separate it at this point, -4 plus or minus something over 4. And I have to simplify this radical, and that I'm going to do off to the side. So the 16 has to wait because we have to multiply before we combine with the 16. So multiplication comes before addition or subtraction. -6 times a -4 is a positive 24. So then when I add those together, I get the square root of 40, which is not a perfect square, but it does have a factor that is. 4 is a factor of 40, and it's a perfect square. So I can factor the square root of 40 into the square root of 4 times the square root of 10, where your square root of 4 then becomes 2, 10 is an even number, but it does not have any factors that are perfect squares other than 1, so it cannot be simplified anymore. So now bring that back to square root of 10. So here's where I'm going to simplify. You can only simplify the whole numbers with the whole numbers. So the negative 4 over 4 I can reduce to negative 1. And then the 2 over 4 I can reduce to 1/2. The 1 here would not be necessary. So just to show that simplifying part. So if I reduce this by 2, I would get 1. Reduce this by 2, I get 2. The 1 in front is not necessary. So I would just write that as plus or minus the square root of 10 over 2. So these would be your exact answers or values or roots. So as far as X-intercepts though, so these would basically be your solutions to the quadratic equation, which are also your roots. Those are the exact values. But when you're graphing, it helps to have these as to convert this to a decimal. So to do that, I'm going to take negative 1 plus the square root of 10 divided by 2, and then I'm just going to round it to the tenths, and I'm going to take x equals negative 1 minus the square root of 10 over 2, and plug that in my calculator, and I end up getting 0.6 and negative 2.6. So as far as what you're required to do, you will be required to solve this. You will be required to get the exact values and get the rounded answers when you're graphing. So if I were to ask what are the X-intercepts, well, let's see. So the roots would be negative 1 plus minus square root of 10 over 2. And those would be your exact solutions. But your X-intercepts are points. There would be 2 points, the point 0.60 and the point negative 2.60. So there are 2 X-intercepts. So these would be your X-intercepts, these would be your solutions or your roots. And zeros are usually called the X-intercepts also. And if you look at your graph, does that correspond with the values that we got? Well, this is, these are by half units, so this is 1 here. So this would be about 0.6. And then this is negative 1, negative 2, this is negative 3 over here. So this would be approximately negative 2.6 if we were to graph it, because it's just a little bit past the negative 2.5. So those do correspond with the values that we got. All right, domain. So the domain represents what x can be, or what numbers we can use for x in our equation. If you look at the graph, so if you think about it, is there any number that you cannot square or can't multiply by 4? No, there are no restrictions on your x values. Also, if you look at the graph, even though it's mostly going up, it does continue to go off to the left
and to the right forever and ever, which means that the domain is going to be all real numbers. So the symbol for that is kind of like a capital R with a line through it like this. So you have to, if you're going to use the symbol for all real numbers, then it has to be written correctly. If you can't do that, then write all real numbers. So that's your choice. You either write the symbol correctly or you write out the words all real numbers. No abbreviations. Okay, the range. So the range is your y values. So domain was your x values, and which is left and right. Your range is your y values, so think up and down. So does this graph ever stop going up? No, it's going to keep going up forever and ever. But at what value does it stop going down? So the lowest point on the graph was that minimum value of negative 5. So the lowest y value, so y can equal negative 5, and it can be everything greater than negative 5. So you're going to write your range as an inequality that states that y can be anything greater than or equal to negative 5. And again, that negative 5 comes from the k value, which is the y-coordinate of the vertex. All right, the y-intercept. This is underlined also, which means we have to show the steps on how we solve it. What's nice, though, is the y-intercept is pretty easy to find. The y-intercept always has an x-coordinate of 0. So if your x-coordinate is 0, all you need to do is put 0 into the equation to solve for x. And then, put 0 in the equation and simplify. So you're going to substitute 0 and simplify. So if I look back at my original equation, the 2x squared plus 4x minus 3. So I'm finding basically f of 0. And I'm going to carve out a little bit of space here. So f of 0. That doesn't look very good. Let me start this over. F of 0 will equal 2x squared plus 4x minus 3. And again, we're substituting 0 because that's the x-coordinate of the y-intercept. If we substitute 0 for these x's, this term becomes 0, the middle term becomes 0, and then you just have this constant, negative 3. So 0 plus negative 3, f of 0 equals negative 3 would be how you would write the point in function notation, but negative 3, 0, negative 3 is how you would write it as an ordered pair. So we showed the work algebraically and we wrote it here. Now let's look at the graph. Does that correspond with what's on the graph? And yes, it does. So this is negative 2, this is negative 4, so negative 3 is right there. So this is the point 0, negative 3, which is my y-intercept. All right, there's one other point that we're going to talk about since it's right here. A lot of times when you're graphing these quadratic equations, it's nice to graph the vertex, the y-intercept, and then the point that's symmetrical to it on the other side of the axis of symmetry. So if your axis of symmetry, which is the center of the graph, is right here, and this point is one space away, your y-intercept is one space to the right, you will also have an additional point that's exactly this one space to the left of that axis of symmetry. So don't forget when you're graphing parabolas that if you've got this point, you can also graph its symmetrical point on the other side of the axis of symmetry. Okay, so that's another good point to use to graph. All right, increasing intervals. So when we were doing our Meet the Parents notes, pull this out here. So in the Meet the Parents notes, if your increasing and decreasing always goes from left to right. So from left to right, the y values are decreasing until it hits the vertex, and then they are increasing. If the parabola was opening down, so if it was opening down, then it would be increasing first, then decreasing. So it's important to think about whether the parabola is opening up or down. So if you look at the graph, I'll zoom out here a little bit so you can see the whole thing. So from left to right, if we were to take these points and look at their y values, they would be decreasing until they hit the interval, until they hit the vertex, and then increasing. So as far as describing your increasing and decreasing values, you always write an inequality, and it's going to look a lot like the axis of symmetry, but instead of an equal sign, the points that are to the left of the axis of symmetry are points that have x values that are less than negative 1. So this side of the graph we would say is decreasing. So these are so this side of the graph is decreasing, and it's decreasing when x is less than negative 1. Notice I do not say equal to, because when x is equal to negative 1, it's neither increasing or decreasing because that's your vertex. So it's decreasing when x is less than negative 1. On the right side, you would say that this is increasing. So the increasing interval, again, is similar to your axis of symmetry, but instead of the equals, we would say when x is greater than negative 1. So these points all over here have y values that are increasing, but the y values are increasing when x is greater than negative 1. So over here, for the increasing interval, that was on the right side, we would say x was greater than negative 1. So that's your interval for when it's increasing. The decreasing interval is when x was less than negative 1. And now we've completed all of the parts that we need to for number 2. All right, so I'm just going to pause that there a second while I move on to problem number 4. Well, that's right. Okay, so in problem number 4, we have an equation now that is also in standard form. Let's see, I was trying to figure out why did I want to do this problem. This problem actually is a lot like number 2. So I actually am not going to do number 4. I'm going to jump right to the number 6, because number 6 is in a different form. It's not in standard form. So problems 1, 2, 3, and 4 are in standard form. I did number 2 for you. So you can do numbers 1, 3, and 4. This problem, number 6, is in intercept form. So intercept form is a little bit different. Another name for it is factored form. And when we get to chapter 3, and we are looking at polynomials of a degree that's bigger than 2, so a quadratic equation is a polynomial equation with a degree of 2. We will see polynomials of a degree higher than 2 when we get to chapter 3. And when we do, we're going to be looking at equations in factored form, which is basically intercept form. What's nice about the factored form is that when you're given the equation, the a value is factored out. Your x, you have two factors here of x minus p and x minus q, or if it was to the third power, you would have another factor that was x minus, say, r. But what's nice about intercept form is when you factored it, if you set each of the factors equal to 0 and solve, so your factor is x minus p and x minus q. But if we were to set this equation equal to 0 and solve, we would get solutions of positive p and positive q. So the opposite, so your p and q in your x-intercepts are always the opposite sign of what is in the factor. But those are the x-intercepts or the zeros of your equation. Now, once it's in standard form, or not standard form, in intercept form, to find the vertex, the x-coordinate of the vertex is, I didn't think I put it, I thought I put it on here, but I guess not. So your h, to find h, the formula to find h is p plus q over 2. So, and once again, h represents the x-coordinate of the vertex. So your vertex then would be the point p plus q over 2, and then the function at that value. So when you figure out what this value is, you plug that into the equation for x and simplify, and that will give you the y-coordinate of the vertex. But notice that this x-coordinate here is also the number that we use in the axis of symmetry. But also think that the x-intercepts are, the axis of symmetry is halfway between the x-intercepts. So if you look at this graph that we're going to see here, we have an x-intercept at positive 2 and an x-intercept at negative 2. Your axis of symmetry, it's going to be a little bit harder to see this one because it's the same as your y-axis. So your axis of symmetry, which goes through the vertex, is going to be the line x equals 0, which is the equation of the x-axis, or the y-axis, axis of symmetry. What am I writing? Axis of symmetry is going to be x equals 0. We can see that from the graph. But if we didn't have the graph, which you're not going to be given the graphs on the next assignment, you'll just be given the equations. So when you're given the equation in intercept form or factored form, the equation is already factored. And what did we use factoring for? Well, we used factoring to solve. So instead of starting with the vertex, I'm going to take this equation and set it equal to 0 to find the x-intercepts. So if I take that negative 2, x plus 2, x minus 2, set it equal to 0, and solve, the negative 2 does not have an x with it, so there will be no solution for it that comes from there. But you take each of the factors that has an x in it, set it equal to 0, and solve. So if I take x plus 2, set it equal to 0, subtract 2 to both sides, and I get negative 2. If I take the x minus 2, set it equal to 0, add 2 to both sides, I get a solution of positive 2. So the factor was x plus 2, but it gives me a solution of negative 2. When the factor is x minus 2, the solution is positive 2. So this is what I'm going to, so your p and your q, it really doesn't matter which one you call which, but p, the value of p is actually negative 2, the value of q is actually positive 2. And they're the opposite of what these terms are. Okay, so as far as your roots or your solutions, if you were asked what are the roots, what are the solutions, you would state x equals positive or negative 2. Or if you were asked to solve this equation. But as far as the x-intercepts go, you need to write them as points. So the point negative 2, 0. So x-intercepts have a y-coordinate of 0. And the other x-intercept is the point positive 2, 0. So it depends on what you're asked to find. If you're finding x-intercepts, they should be written as points. If you're asked to find the roots or the solutions, you can just say x equals positive or negative 2. The zeros are your x-intercepts. All right, so now let's go back to the vertex. So the p and q, the x-intercepts, are pretty easy to find when it's in factored form. The vertex, however, you have to take, so p, like we said earlier, so p is actually equal to the opposite of this, negative 2. Q is actually equal to the opposite of this, which is positive 2. So if you want to find the x-coordinate of the vertex, which we call h, h equals p plus q divided by 2. Make sure you're not using the values that are in the factors. Make sure you're using the actual values of p and q, not the numbers that are in the factors. So negative 2, in this case it doesn't matter because they're the same number, but in this problem up here, just to show you a difference, the p is positive 5, your q would equal negative 3. So when you are finding h and you're taking p plus q over 2, it will matter. You don't want to use these numbers. You want to use the actual value of p and q, which are the opposite of what are in the factors. So when you add that p and q together, 5 plus a negative 3 divided by 2, so when you add the 5 and negative 3 together, you get a positive 2 over 2, which would then equal 1. So that is the x-coordinate of your vertex for this problem. And then you would substitute 1 now into this equation for x to find the y-coordinate of the vertex. But had you taken the negative 5 and 3 and added those together, instead of positive 2 in the numerator, you would have gotten negative 2. So it's important that you find the actual values of p and q by changing those signs, and then add those together and divide by 2 to get your h value. All right, so going back to this problem that we were doing. All right, so we're doing the same thing here. So we're taking the p, which is negative 2, plus the q, which is positive 2, divided by 2. Lots of 2's. The numerator, negative 2 plus 2, is 0. And 0 divided by anything is 0. So that tells us the x-coordinate of our vertex is 0. To find the y-coordinate of the vertex, also you must show this work algebraically. Even if you can figure it out without, you must show it algebraically so that you get in the practice of doing it when it's not so easy to figure out. All right, so k, how do you find k? Well, k is equal to the function when you substitute that h value. So if I know that the x-coordinate of my vertex is 0, I substitute that in to this equation, or whatever number you got for h. All right, so we're substituting 0 in for x. Now simplify. Order of operations, simplify your parentheses first. So 0 plus 2 would be 2, 0 minus 2 would be negative 2. And when I multiply negative 2 times positive 2 times negative 2, I get a positive 8. So that is the y-coordinate of my vertex. So now that I've got my vertex, I would then graph it if I didn't have the graph already. But the graph at least shows us we are doing this correctly. So that's your vertex. It does correspond with what we found algebraically. All right, so the axis of symmetry is always x equals the x-coordinate of your vertex, which is 0. Don't forget the x equals part. The max or your min. Well, this time the parabola is opening down. Not only can we see it, but if we look at the a value, when your a value is negative, when the a value is negative, that tells you that the parabola is going to open down, and the vertex will be the highest point on the graph, so you're going to have a maximum value. The max is going to equal the k value. So I'm just going to cross that out. It's a maximum, not a min, and it's going to equal 8. So your maximum value equals 8 at the x value of 0. But the maximum value is 8. So it's always equal to k. But it happens at when x equals 0. All right, domain. So domain, again, is going to be all real numbers. You're going to get tired of writing that, but make sure you write the symbol correctly. Either write a capital R and then put the line here, or what I like to do is I put 2 lines and then an R symbol. So that works for that. Your range. Since your parabola is opening down, your y values are going to be less than or equal to, since the vertex has a y value of 8, the y values can equal 8 or anything below it. So y is going to be less than or equal to 8 is how you're going to write the range. The y-intercept. So if we didn't have the graph, and to show this algebraically, your y-intercept, you're going to substitute 0 for x and simplify. And that works for all functions. All of these equations have the same rule of thumb. Basically, when you're trying to find your y-intercept of anything, substitute 0 for x and simplify, because the x-coordinate will always be 0 for all y-intercepts. So if I take my equation and substitute 0 for x, negative 2, 0 plus 2. I know we did this earlier, but it doesn't matter. You're to show all these steps algebraically, so then when the numbers do change, that you understand what to do. So since 0 is our x value for the y-intercept, substitute 0, simplify, you get negative 2 times negative 2, which again will be a positive 8. So f of 0 equals 8 is how you'd write it in function notation, but then as a point, you would write it 0, 8. All right, so every once in a while, the y-intercept and the vertex happen to be the same point. That only happens when the vertex is actually on the y-axis. That doesn't always happen. All right, so increasing intervals. Since our parabola is opening down from left to right, the y values are increasing. Then when it hits after the vertex, it's decreasing. So if we think about, well, if this is increasing, what are the x values on this left side of the parabola? Well, this is the line x equals 0. Anything to the left of that would have x values that are less than 0. So the increasing interval will be when x is less than 0. The decreasing interval this time is the right side, and all of these points have y or x values that are greater than 0. So the decreasing interval will be when x is greater than 0. Notice they do not don't put lines underneath. It does not equal 0. When x equals 0, it's neither increasing or decreasing because that's the vertex. So your increasing interval was when x is less than 0, and your decreasing interval is when x was greater than 0. All right, so that ends number 6, and that was intercept form, or factored form. And number 5, I've started it for you, but you need to finish showing all the work for the X-intercepts, zeros, the Y-intercept, and fill in the rest of the information. But these are the only 2 that are in intercept form on this assignment. Now we're going to jump to number 8, and this is in vertex form. So the reason why this is, you can tell it's in vertex form. So if you look at vertex form, you've got sometimes you'll have a coefficient in front, sometimes you won't. If there was no coefficient in front and it was just x minus 3 in parentheses squared plus k, then your a value would just be 1. Also, if there was no h value, or if your h value was 0, you would just see x squared and not x minus 3. If your k value is 0, sometimes the equation will look like this if there's no transformation vertically up or down. All right, so you can see that this is in vertex form. Hopefully you can see that, tell that the 2/3 is your a value. So from looking at the equation, a equals 2/3. Your h is the opposite of what's in here. So h is positive 3, and k, it stays the same, is positive 5. So your vertex is just, you really don't have to show work for vertex form. If you're given the equation in vertex form, there really isn't any work to show for finding the vertex other than identifying the a, the h, and the k. So identify a, h, and k, but then write your vertex as the point 3, 5. So that is your h and k. There's really not a whole lot of work to be done to find the vertex. And if you look at your graph over here, this is the point 3, 5. So 3 is halfway between 2 and 4. 5 here, halfway between 4 and 6. I also like to draw my axis of symmetry, and you should also after you graph that vertex. So this is my axis of symmetry, and it has an equation of x equals 3. Notice it's the same value as the x-coordinate of your vertex. So back over here, axis of symmetry, you must have x equals. Then put that 3. So the vertex is a point, the axis of symmetry is a line. Your max or your min. So this time, if you look at your a value, it's positive, which tells you your parabola opens up. So the vertex will be the lowest point on the graph, so it will not be a max, it will be a minimum value of k, again, which is 5, when x equals 3. So your minimum value is k when x equals 3. And that, again, comes to that vertex. So your minimum y value in the graph is 5. All the other y values are going to be greater than 5. So that also speaks to your range. So since y is the lowest value on the graph and all the other y values are greater, your range would be y values that are greater than or equal to 5. So that's how you would just define your range. Domain, once again, is going to be all real numbers. Make sure you write that symbol correctly. Your zeros, roots, solutions. Now this one's going to be a little tricky, so pay attention. You still, whenever you're finding x-intercepts or solutions, you to a function, you set the function equal to 0. So I've got a lot of space over here. So I'm going to take that 2/3 x minus 3 squared plus 5 and set it equal to 0. Alright, so this is kind of new. We used square root method to solve quadratic equations that had an x squared term but no middle term, x squared terms and constants. Well, we are also going to use the square root method for this problem, but instead of just x being squared, we have something in parentheses squared. So when you're using square root method with the vertex form, it's a good idea when to use this. So when you have vertex form, set the equation equal to 0. We want to isolate this x squared part. So step number 1, move the k value over, or eliminate it from the left side and move it over here to the right. So now 2/3 x minus 3 squared equals -5. So that's our new equation. The next thing we want to get rid of is this 2/3, or eliminate. So you could do this in 2 steps. You could multiply both sides of the equation by 3, or multiply by the reciprocal of 2/3, which is 3/2. So I could multiply by 3 and then divide by 2, or just multiply by the reciprocal. So then the 3's will reduce, the 2's will reduce, and now all I have left on the left side is the x minus 3 squared. But on the right side, we've got -5 times 3, which will be -15 over 2. And if you need to, write that as a fraction, multiply the numerator and denominator, and you still get -15 over 2. All right, next step, what do? Get rid of the square. Well, what will undo or eliminate a square? A square root. All right, so we square root the left side, that eliminates the square. Now we're down to just x minus 3. But the right side now, we have a problem. You cannot take the square root of a negative number and get a real solution. So if you have not been introduced to complex numbers or imaginary numbers, at this point you would just say no solutions. However, we have done problems like this. We have solved equations that have complex roots and imaginary solutions. So we need to simplify this radical. So we're going to keep going here. The -15, I would recommend, I'm going to run out of space here. So let me do it below here. All right, so the -15, I would factor out the negative and make it square root of -1 times the square root of 15 over the square root of 2. So that's what this would look like if I factored it out. Now, why do I want to factor it this way? Well, the square root of -1 is where the I, or imaginary number, comes from. Square root of 15 cannot be simplified, nor can the square root of 2. But now we have another problem. You cannot have a square root in the denominator. So to make the denominator a whole number, we're going to rationalize the denominator by multiplying the numerator and denominator by square root of 2. So when you multiply the square root of 15 times the square root of 2 in the numerator, you get square root of 30 underneath that radical. The square root of 2 times the square root of 2 is square root of 4, which basically simplifies to 2. So when you multiply a square root by itself, it becomes the whole number. So, and also over here, let me move this over a little bit. Whenever you square root both sides of the equation, don't forget your plus and minus. We have 2 roots. When you take the even root of both sides of the equation, there are 2 roots, the positive and the negative. Now I'm going to bring this back up here. I square root of 30 over 2. All right, well, the x is still not by itself, so we have to add 3 to both sides. So the x now is by itself on the left side. This 3 is a real number. This is a complex and a radical, so these are not like terms. You cannot combine them, but you can rewrite this. The 3, which is the real number, should go first, and since it's positive, I don't need to put a sign in front of it. Had this been a positive here and we were subtracting to both sides, you would need to put a negative in front of that. But then put your plus minus I square root of 30 over 2. Or you can write it as 3 plus or minus the square root of 30 over 2i. So either one of these would be acceptable in my class, but as you get into higher level math classes, the I should technically go at the end. All right, so that's how you would write your roots or solutions. X equals 3 plus or minus square root of 30 over 2i. Now, unlike some of the other problems, we do not need to change this to a decimal and graph it, because the point, if you look at your graph, whenever you get an I or an imaginary number or a complex root, that tells you that there are no x-intercepts. If you look at this graph will never cross the x-axis because it starts here at the point 3,5 and it's opening up. So it will never turn around and cross the x-axis. So one big clue, when you are trying to solve a quadratic equation and you get a negative number under the radical, your graph will not have any x-intercepts. So as far as the x-intercepts go, you would say no x-intercepts or none. Or you would say no real roots, but we do have complex roots. Okay, moving on now. Y-intercept. You can still get the y-intercept. So to find the y-intercept, once again, you substitute 0 for x and simplify to find your y. So take your equation and substitute 0 for x. Your equation is 2/3 x, which we're replacing with 0, minus 3. So this is your equation up here. Substitute 0 for x. And then simplify. So we just basically substituted 0 for x in the equation. Order of operations, do what's in parentheses first. 0 minus 3 is negative 3. Order of operations, square next. So the negative 3 squared is a positive 9. Then multiply your 2/3 times your 9. If you need to, put that over 1 and multiply your numerators, which gives you 18 over 3, which is 6. Then add your 5 and you get 11. So f of 0 equals 11. That's how you would write this in intercept or function notation, but as a point, it is the point 0, 11. Now, does that correspond with what was on our graph? Yes, it does. So 10 was here. This is my y-intercept at the point 0, 11. Increasing and decreasing intervals. Almost done. So when we look at the graph from left to right, this is decreasing, this is increasing. Your axis of symmetry is at x equals 3. So the vertex has an x coordinate of 3, which means all the points to the left of it have x values that are less than 3. So the decreasing interval is when x is less than 3. The increasing side is to the right, and all of these points have x values that are greater than 3. So Going back now over here, the increasing interval was when x was greater than 3. Your decreasing interval is when x is less than 3. All right, so now that we've done a problem in vertex form, intercept form, and standard form, it's time for you to do the rest on your own. Good luck.